There we go. So this is the version of Scratch we will be using. It is not Scratch 2.0. Scratch 2.0 is this browser-based Scratch, which if you're familiar with Scratch, it's probably the Scratch that you use. This is an older version that you actually have to download on your computer. Got my Scratch right there. All right, I'm going to send this download out in chat. Oh my gosh, okay, I have a... Oh no, I was not showing my screen. Okay, well this is all you've been missing is me talking about this right here. Sorry about that. That's okay that if you don't have your Raspberry Pi. So I sent this out in chat. This is the download for the older version of Scratch. You might not be able to get it downloaded and installed on your computer by the time we're working with it tonight. But if you want to and work with the YouTube recording at a later point, that's fine. You know, this will be up on YouTube most likely this evening. I've been pretty consistently able to post it the evening, but if not, it'll be up tomorrow morning. Okay. I know many of you have worked with Scratch, but this is a slightly different interface. We are starting as though you have never used Scratch before. So just kind of go into it with that attitude. I will be offering more challenges, and you can definitely, if you've used Scratch before, kind of explore on your own and do a little above and beyond. But please try your best to stay engaged, because some of the interface is different from what you've used with Scratch 2.0, and we're going to be using this Scratch to do physical computing. You know, light up an LED with your Pong game, that sort of thing, which is very cool. Very excited to get the opportunity to do that in a few weeks, and you've got to be familiar with the Scratch interface in order to do that. And oh, hold on. I'm getting some questions, that's why I paused. Amelia, please just let Mr. Dubik know. Sorry that you're missing, but completely understandable. I hope you enjoy your trip and we can get you caught up. Kate says that it is super easy to download and it's super fast, so I'm glad. So Scratch is already on your Pi desktop. It should be already on your Pi desktop. It's a little cat head. I don't know if you guys can see mine on my desktop, so I'll pull it up here. Just pull up. There it is. Well, it's probably very difficult to see. Let's see if I can change this at all. Should look something like this. Yes, if you're on your Raspberry Pi, you should open this one on your Raspberry Pi. I can't do the webinar from a Raspberry Pi, so I'm just going to be showing you Scratch 1.4 on my laptop. And I shared this link for those of you who don't have your Raspberry Pi tonight if you still want to follow along. Or for those of you who want to follow along later but still don't have a Raspberry Pi. Okay. So while you are opening your Scratch, I'm going to go through a little bit of an introduction. For those of you who've never used Scratch before, Scratch is a programming language. It was designed for kids 8 to 80. So it might seem a little bit childish, right? There's that little cat there. And you know, it looks like little puzzle pieces are what you're using. You're not typing out code like you might imagine. But it really is quite sophisticated. It was developed by MIT, the Institute for Technology. It's actually used in Harvard students' Intro to Programming class. At Harvard. So it's used to introduce programming. It starts out really simple, but that by no means means that it's not powerful. It's extremely powerful. You can make really, really cool games with Scratch, really complicated games. And it's fun. It's a fun way to learn to program. I love Scratch. I teach it in my high school classes. We do a lot with it, and I think it's just very enjoyable. You can create content like stories or animations, as well as games. And we again will be using version 1.4. This is actually downloaded onto your device, so it's already on your Raspberry Pi, and you can follow the link I sent out to download it onto your laptop or computer or desktop computer. And this version does not require the internet. Version 2 is not on the Pi, and we will not be using version 2. I'm not against version 2, that's what I teach in my classes, it's really great, but this is what we're going to be using. Okay. Raise your hand if you want me to wait for a minute while you're getting ready, you're getting Scratch open, that sort of stuff. So raise your hand if you need a minute before we continue. All right. Got a few hands? No worries. Send me a message if you have a question. Oh, good. Getting some messages from people that they're ready. That's good. Just waiting, and it looks like one more hand. So whenever you are ready, just go ahead and put your hand down. Great. Wonderful. So we are going to be following, I'm going to just open Scratch on my computer. And instead of following this wonderful presentation, I'm going to show you on my computer. So what this means is, I know some of you have used Scratch before, and you're going to really be wanting to mess around with all the different blocks and stuff. But when I say eyes on my screen, I want you guys to take a moment, take a break from the Raspberry Pi for a moment, and watch what I'm doing, and then I will ask you to do it. But it's really important that you watch my screen when I ask you to, so that way you kind of know what's going on. Things are going to start out super simple, but they are going to get more complicated. And if you don't know what I'm talking about, you're going to get a little bit lost later down the road. So please, 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 I know I'm not there to check on you, but when I say eyes on my screen, please focus on what I'm doing, and then I will give you guys time, especially at the end of class, to experiment and kind of play around on your own. Okay, so quick introduction to this Scratch interface. This is your sprites area, where I am right down here. Notice that right now we only have one sprite. It's named Sprite 1. Okay, and we'll explore this area in a little bit. This sprite is going to act out different commands that I give it. And those commands are in the form of a sequence that you put onto your, called a script. And basically a script is just a list of commands, and you build that within the script editor right here. And you build your script out of these blocks. So this is your sprite area, your script editor with the list of commands that your sprite is going to act out. And this is called the blocks palette. And this has all of the different commands that you can get your sprite to do. And notice that there are different categories, and the color of the block corresponds to the color of the category. That's going to help you out a little bit later when you're trying to follow along and match where I am. This area over here to the right is the stage area. This is where you're going to see your sprite act out the list of commands that you give it. Any questions so far? No? Okay, eyes on my screen. You're going to go to Control in just a minute. First, watch me do it. And we're going to go ahead and add a block to this script area. And to do that, we're going to add this when green flag click block. We're going to add this one into the script area. You click and drag, and then you drop it. Go ahead and try that out. You grab a block, click and drag, and drop it. Alright, eyes on my screen. Alright, I made a mistake. Not really, trying to show you guys how to do this. But I added 2 blocks onto the script area when I only needed 1. To fix this, I can either right-click the extra block and select Delete, or I can click and drag the block back onto the blocks palette and release. Go ahead and try that out. Either right-click and delete the block, the extra block. First, you're going to need to pull an extra block onto the block palette. Either right-click to delete it, or click and drag it back onto the block palette to delete it. Laura, you just got to go to the right section, so click Control. You're probably in the motion section. You need to be in the control section. Alright. Eyes on my screen. Eyes on my screen. This is called a hat block. This is how a sequence of commands is going to start. When I go to the motion section of the block palette, these kind of thinner blocks are known as stack blocks. S-T-A-C-K, stack blocks. And this is what the majority of your code is going to look like. The start of your code is a hat block. The majority of your code are these kind of thin stack blocks. And as you can see, as I kind of just pull a few out and stick them together, they fit together like puzzle pieces. These are the actual commands that the sprite is going to follow or act out. The hat block is what the sprite is kind of quote-unquote listening for in order to start the commands. So I'm going to go ahead, eyes on my screen, add a move 10 steps block over till you see that white line. And that means that the puzzle pieces are going to click together, and then actually click the green flag to see what happens. Go ahead and try that out. Alright, so some of you who are adamant clickers may see that your cat actually ends up going off the screen. If you have this issue, eyes on my screen, anytime that the cat kind of goes off the side, you're going to grab the go to X0, Y0 block, and you're going to click it just once. and that'll put Scratch Cat at the center of your screen. Go ahead and try doing that. Just grab the go to X is 0, Y is 0 block. Click it, and then delete that block. There you're just executing one command. You're just telling the cat, go to the center of the screen, and then you're deleting that block. Laura, I'm going to call on you. Hi, Laura. Hello? Okay. Laura, if you look up here, there should be a control category. When green flag is clicked and it looks like a green flag, should be up there. Should be the first one on the list. Make sure that you're following this video and not just listening. Should be right up there. I clicked the control category. I was on the motion. I clicked control, and it's the first one. Laura, let me know if you're doing this. You're hitting control, and you still don't see it. Laura, do you see something like this? If so, use the scroll wheel or click and drag this up to try to get to the top of the list. Laura, if the thing on the top is wait 1 second, you just got to scroll up like I'm doing right now. That just means you're all the way scrolled down like this. See how there's a scroll bar here? You need to scroll up. Alright, Laura, let me know if that doesn't work. Okay, eyes on my screen. So, what's happening is when the green flag is clicked, this line of code gets run. But the cat doesn't move very far. What the cat is actually doing, or what the computer is doing, is taking this image, this flat, simple image of a cat, and moving it over by 10 pixels. Okay, and you don't need to know the term pixels. It's just it's like a measurement, a unit of measurement used in computing. But it moves it over a very small amount. So what I'm going to do now, I want my cat to always start out on the left side of the screen. And if I kind of hover my mouse over here, you can look down in this section and it tracks Oh, Laura, if you're using Scratch 2.0, then your controls are going to be different. Laura, if you're just going to scratch.mit.edu and using Scratch, then yes, it's going to be in events. But that's why you got to use 1.4. That's the one that you actually have to download. Okay, I'll talk to you in a minute. Okay, I'm trying to think back to where we were. Okay, so now I'm going to do a code. I want my cat to start over here and walk across the screen. So I'm going to say, cat, go to, and let's take a look at this. Eyes on my screen. You can think about the Scratch background like the XY axis, which I know only some of you have gotten to in math class. But all you have to think about is that the cat's position, or any of the sprite's positions, can be thought about by two values, an X value and a Y value. If you want the cat towards the right side of the screen, you make the X value very big, like 150. If you want the cat on the left side of the screen, you make the X value very negative, like negative 150. If you want the cat really high on the screen, you make the Y value very big, like positive 150. And if you want the cat very low on the screen, you make your Y value very negative, like negative 150. Okay, this is the XY plane. So that means, again, eyes on my screen, I have this go to block, and I can demonstrate that. If I want the cat to be on the right side of the screen, I'm going to change X to a positive high number, 150, and leave Y at 0. And I can change X to negative 150, and now Scratch Cat is on the left side of the screen. I can make X 0, because 0, 0 is going to be the center, and I could make Y 150, X 0, Y 150, when Scratch Cat appears high on the screen, X 0 and Y negative 150, and Scratch Cat appears low on the screen. Who can either type in and tell me, or raise their hand and tell me what numbers I could use to make Scratch Cat appear in the bottom right portion of the screen? Bottom right portion of the screen. Hey Ava, what do you think?
You can do like, for X you can do like 200, and then for Y you can be like negative 90.
Nice! Let's see if that works. Great. Absolutely. I'm going to mute you. So Ava chose a high positive X value to make it on the right side of the screen, and a very negative Y value. And I'm saying very negative because I don't want you to think a very low number and get confused. Does she mean a small number that's negative? Does she mean a big number that's negative? So that's why I'm saying very negative. So negative 90, negative 150, and that'll be the lower side of the screen. Okay. Okay. Okay, good. So I'm going to have Scratch Cat go to 0, 0, which is the center of the screen. But actually, I want in my code, I want Scratch Cat to start on the left and move all the way across the screen to the right. So eyes on my screen, I'm going to have it go from negative 150. I'm going to have Scratch Cat start at negative 150, 0. And I actually want him to start there every single time the code is run. So I'm going to make that the first step in the first command in my sequence. Below that, I'm going to put move 10 steps. So now when I click the green flag, every time I click it, the first thing Scratch Cat does is return to negative 150, 0, then moves 10 steps. Now, who has a suggestion on how I can make Scratch Cat move a little bit further? or further at all. How about adding another move 10 steps block? Another option is changing the value within the move steps block. So instead of moving 10 pixels, ScratchCat moves 50. Go ahead and add a sequence that looks like this, including the go to block. Someone said increase the number of steps. Someone said use the glide block. That would actually work. I'll show that in a little bit. I want people to get used to the actual functions, and we're not going to use the glide block yet. So someone pointed out that you could increase the number of steps. But it doesn't look very good. And you don't always see the cat returning to his original position. So eyes on my screen. The reason you don't always see the cat returning to his original position is because the code is happening so fast, the computer doesn't always have time to show the user. It's happening faster even than our eye can see. So, under control, again, eyes on my screen, we're going to add a wait 0.5 second block in there. Wait half a second. So go to that position, wait half a second, move 50 steps, wait half a second. Move 50 steps, wait half a second. And I'm only halfway across the screen. I gotta keep adding, right? Move 50 steps, wait half a second. Move 50 more steps, wait half a second. Move 50 more steps. Well, this is getting very labor intensive, right? We got a lot of these repetitions. And it does kind of look like ScratchCat's now walking across the screen, but we've got so many blocks that say the same thing. So eyes on my screen. Instead of just repeating these number of blocks, we're going to add what's called a loop block. It's under control, and it looks like this. It looks kind of like a C. It says repeat 10. We're going to click and add that into the script editor. And then eyes on my screen, because this is important. When you click and drag a sequence or a list of commands in Scratch, a list of blocks here, whatever block you choose, it also selects all the blocks beneath it. So if I select this move block, it will select this one and all the ones beneath it, just like this here. If I select the go to block, it will select that one and all the ones beneath it. Okay? So I'm going to select this wait block and go ahead and delete all of those. Eyes on my screen. Instead of having separate ones, I'm going to fit this wait 0.5 seconds and move 50 steps into the middle of this repeat block. And what's going to happen is ScratchCat is going to go to the left side of the screen. Then he's going to wait 0.5 seconds, move 50 steps, and then the repeat block is going to go back to the top. Going to wait 0.5 seconds, move 50 steps, wait 0.5 seconds, move 50 steps, and it's going to repeat whatever commands are kind of enclosed between the top and bottom of this repeat block. It's going to repeat them 10 times. Notice that the go to block does not get repeated. And we're going to take a look at why in a second. So eyes on my screen. I want you guys to try this out. So now, eyes on your screens. Try this code out. You can change the number of times it gets repeated. Mine now moves 45 steps, and that gets repeated 7 times. All right, raise your hand if you need more time with this, or if you're confused or completely lost. Raise your hand if you need more time. No? Okay, great. So what's happening is that the computer is just moving this flat image across. It's just doing doing the commands that you tell it to this image. So it's placing the image where you want it, and then it's waiting, moving it, waiting, moving it, waiting, moving it, etc. The computer does not understand that this image is like it's a biped, right? It's supposed to be an animal with 2 legs, and that the user might expect it when it's walking to use those legs. The computer does not understand that at all. It's doing exactly what you tell it to. So if we want to suggest some amount of animation, if we want it to make it look like Scratch Cat is moving, we have to add that in as coders. Luckily, Scratch makes that pretty simple with something called costumes. So again, this is one sprite. And we see this sprite is going to act out the commands that we give it. This single sprite has multiple costumes or images that it can look like. But note that it's just one sprite. Each costume does not have its own sequence of commands. If it looks like if it's wearing costume 2, it has the same script that is as if it was wearing costume 1. Alright, and that's over in the script editor. Make sure your eyes are on this page. It just changes what the user sees. Under the looks category, you can choose the block next costume, and add it to your loop. Now what's happening is it starts with costume 1, moves the image, switches to the next costume, waits, moves the image, switches to the next costume, etc., etc. And that creates a little bit of animation. Go ahead and try that out. Alright, eyes on my screen. I have a question for you. Notice that we have one block, the go to block, that is not within the repeat block. I'm going to go ahead and add it as the first line in our repeat block. Now when I hit the green flag, this happens. Can someone tell me what mistake I'm making? You can raise your hand or you can type it in. I'm going to give everyone a moment. I see someone already raised their hand. So in just a minute, Brianna, I'll call on you in just a minute. But I want to get everybody take a look and try to figure it out. Take a look at this code. What is going on here? The only thing I changed is I moved the location of the top line and now it's not working. Someone said repeat teleport. I don't know what that means. All right, Brianna, I'm going to unmute you. What's going on?
The reason why it keeps the command says go to the back to where the start is. So whenever it moves the steps, it'll just go right back to where it started.
Right, because it's part of the loop. It gets repeated too. Thank you. That is correct. So what Brianna is saying that it will go to the original start position, it will move to the right, and then when the loop restarts, it goes back to the original position. So the order in which you give your blocks, or the order in which you place your blocks, is super important. Very, very important. Okay, I'm going to do hands down. I want eyes on my screen, and I'm going to show you guys a couple things, and then I want you guys to come up with a dance on your own. Okay, so eyes on my screen here. What I'm going to do, I'm going to have Scratch Cat kind of walk to the center of my screen. So I'm going to test that out. Does that look like the center? No, that's a little bit too far. Maybe I'll make him start at -200. Notice I'm kind of guessing and checking right now. You could actually do the math to figure out exactly what you would need, but that looks about right. So I'm going to have Scratch Cat walk to the center of the screen, and then what I want you all to do is kind of mess around with some of the blocks to see what you can make Scratch Cat do. So for right now, eyes on my screen, but then in just a minute I'll ask you to kind of check stuff out. So the first thing I'm going to do is add a repeat block, and within that repeat block I'm going to want Scratch Cat to kind of spin around. So I'm going to have him spin 15 degrees, maybe kind of move back and forth within that. And I should have said this before, but moving 10 steps makes Scratch Cat move to the right. Moving -10 steps makes Scratch Cat move to the left. Maybe I'll get some weights in there, just so the user has a moment to see. And I'm going to make this really short. 0.1 second. Just 1/10 of a second. Have that repeat 10 times. I'm just kind of trying stuff out. I want to see what will happen, kind of make him look like he's dancing. And it looks a little weird. Maybe I want him to turn 30 degrees. Or maybe 36 degrees. That way he turns in a full circle. Right? 36 times 10 is 360. And I decided, hey, I don't like him to back up. I just want him to kind of move forward in that loop. Uh-oh. Alright, notice I'm just kind of playing around till I see something that I like. I'm going to have him started pointing in the 90-degree direction, pointing right. And then maybe I'll throw in something crazy, like a color effect. I don't know what this does, so I just want to try it out. Alright, so my code starts, points to the right. You know, he starts over at the left area, walks forward, and then he does a little spin. And maybe I'll have him spin in the other direction, so I can right hit duplicate, and instead of having him turn to the right 36 degrees, I'll have him turn to the left 36 degrees. Right, and he's just turning 36 degrees, but this is going to get repeated 10 times. Alright, so try it out. Go ahead and try to get Scratch Cat to do your own little dance. Just try different blocks, mess around, and see what you can get it to do. I will say, eyes on my screen for 1 second. I'm sorry, I know I told you not. You're going to want to add things called initial conditions. Note that I have originally Scratch Cat points in direction 90. And if you click on this, it's like a little drop down. That lets you know Scratch Cat starts by pointing to the right. And you can look up here, that blue arrow, that blue line points to what, if he's pointing that way, that's pointing up. Well, we want him to start by pointing to the right. And we want him always to start over here. And we probably always want him to start by being the right color. So set color effect to 0. Those are initial conditions so that every time your animation starts, it starts the same way, no matter what your animation is. Alright, go ahead, try out different stuff, and let me know if you have any questions, concerns. I wish that we could share it. For those of you working on a laptop or computer, if you want to share your screen at the end, go ahead, go for it. Also, if you're working on an iPad, you can turn your camera on your iPad and show us and easily, those of you working GoToWebinars on an iPad or a tablet device, you can easily show us your Raspberry Pi screen using the camera on the iPad, and I can walk you through that. Take about 10 minutes, make yourself a little dance. I'm giving Scratch Cat a little crown. At the end of my dance. And so if you have a lot of Scratch knowledge, go ahead and try to do something crazy. Yeah, Brooke, programming Scratch really is similar to programming Mindstorms. Both of them use that kind of drag and drop coding, so your Mindstorm programming is really going to help you out with Scratch. Does anyone have a dance that they want to share? Or that they're able to share? It's only been a couple minutes. I'll give people more time. I think it's only been 3 minutes. I'm just so excited to see the dances. That's my issue. I'm going to go ahead and add the link to download Scratch 1.4 to your computer on Edmodo. So. To be clear, right now, you do not need to copy what's on my screen. I want you guys kind of experimenting and making your own dance. If you would like to copy the code on my screen and just modify it, so change the number of steps or change how it rotates, that is absolutely fine. Do something, add a sound in. Say sound meow. That won't annoy anyone in your household. But notice, no matter what the costume changes, same content. All right, checking back in. Anyone want to share their? No? No volunteers? All right, send out the Edmodo code. Okay, before we keep going, I want to do a quick poll. So I'm going to do a few polls here. First, how is my